Okay, so welcome to part 2 of electron configuration. In the previous video, I did a quick intro to electron configuration, and now we're actually going to go into the meat and potatoes of it. Is that an expression? Anyway, okay, so there are three things you need to know when you are starting electron configurations, and they are listed right here. They're also in your PowerPoint, okay? So the first thing you're going to do is you are going to locate the element that you want on your periodic table, okay? So we're going to start with the simplest element, which is why I wrote hydrogen up here. So hydrogen is the simplest element on the periodic table, and it is right there, the first element, right here, okay? Now, I actually want to show you some other things on the periodic table as well, and you should highlight them as I show them to you on your own annotated periodic table, okay? So we found hydrogen is number 1 on the periodic table, and the second question you have to ask is, what period is the element in? Now, we already wrote this down in a previous class. Period is row. So on the periodic table, I have 7 rows, okay? So here are my 7 rows on the periodic table. They go 1 through 7, okay? Which means hydrogen being in the row number 1 or being in row number 1 is in period 1. So hydrogen is in period 1 of the periodic table. Now the next thing you ask is what block? So I asked what period, now what block is hydrogen in? Now, remember the sublevels that we put in our apartment building? Those are actually present in the periodic table itself. I had to just make it a little bit smaller, zoom out, just so I can highlight everything, okay? In the periodic table, the first two columns, okay, these first two columns are called the S block. And the big squarish kind of area here, that's the P block, okay? Now over here, helium is still in the S block, except helium is a noble gas. So on your periodic tables, you should have colored helium green. And helium is a noble gas, so it likes to hang out with other noble gases in column 18. However, helium should technically just be right here, so it is part of the S block. So if I ask you what block is helium in, you would say it's in the S block, okay? The P block is this squarish area right here, this entire area other than helium. It's very hard to draw because helium is in the way, okay? So it's like here, okay? That's the P block, this entire area. And then the D block is the middle here. This is the D block. This middle section is the D block, okay? And then this over here, down here, this is the F block, okay? Now, pay attention to the D block. See how in parentheses next to the letter D, it says D is n minus 1. So that means when we are talking about elements in the D block, when we are talking about what row they're in or what period they're in, we always have to subtract a number from the physical period they're in. So, for example, let's keep using blue. If I want to do the electron configuration of manganese, okay, if I want to do manganese and I ask you what period is it in, you might look over here and say fourth period, fourth row, because manganese seems to be in the fourth period. However, n minus 1 means 4 minus 1. Manganese is actually in the third period D block. So we call this row 3D. That means this one is going to be the fourth period D block because 5 minus 1 is 4. Then this one is going to be 6 minus 1, 5D. And then this last one is going to be 7 minus 1, 6D. Okay? The reason is the periodic table should actually be one row up this middle section. However, in order to mirror real life, where the where the s orbital here, the 4s, is lower in energy than the 3d orbital. Remember, in our Aufbau order, 4s comes before 3d. In order to mirror that, the entire d block has been shifted one down. Okay, so because of that, d block is 1 minus the actual physical period it's in. Okay, and there's another block that is similar to that, and that's the F block. F block I put in green. F block is actually n minus 2. So it's in the physical sixth period because it's actually supposed to be here and here. But 6 minus 2 makes this 4F, and then 7 minus 2 makes it 5F. This is also why there is no 6F, there is no um, 7F. Okay. Now that you know the main areas of the periodic table, SPDF, you are ready to do electron configurations. So here's the first thing you do, right? You locate the element, you figure out what row is the element in. For hydrogen, it's in the first row. And then the block of for hydrogen is the S block. So now you look at your Aufbau order, and the period and the block tells you the stopping point for your element. So for hydrogen, the starting point and the stopping point are both the same. You start at 1s and you stop at 1s. So all you write is 1s. Okay? Now, how many electrons does hydrogen have? It has one electron. That electron we just put in the first energy level's S-type sublevel, or the first floor's S-type apartment. We put the person in there, or the electron in there. Okay, so this is the principal quantum number, or the main energy level. The S is the sublevel, and then the 1 is the number of electrons in there. Okay, I'm gonna make the 1 the same color. There we go. This is called the complete electron configuration of an element. Now, hydrogen is really simple. So because of that, we're going to try to do slightly more advanced ones. So what we're going to do is we are going to do all of the second period elements. Remember, second period is the second row. So I have going from left to right, starting with lithium. Use light blue. Starting with lithium in the second period, that's the second period. I have lithium, beryllium, then I have boron, carbon, nitrogen in my notes, oxygen, fluorine, and then the last one is neon. Okay, so I've written all of them out so that we can do the electron configurations for all of them. Okay, these are all my second period, second row elements. Okay, so what's the period? Second period. What's the block for lithium? Lithium is in the S block. It's in the red color block, right? So here's what I do. I find second period S block is 2s. That's my stopping point for lithium. Okay? So you start here every single time. Remember, you have to start at 1s. This is your stopping point, the circle. The start is always 1s. So I have to write 1s, and then the next one is 2s. We are reading these arrows diagonally from back to front, like I said in the first video. Okay? Now, lithium has 3 electrons. Lithium has 3 electrons. That's on your periodic tables. Lithium has 3 electrons. How do I distribute those electrons? I distribute them based on the number of electrons that each type of apartment can hold. An S-type apartment has 1 room or 1 orbital and can hold a max of 2 electrons. Remember, in our notes, we had a little table. S can hold a max of 2, P can hold a max of 6, D can hold a max of 10, and F can hold a max of 14. Okay, so that's what I am doing. Whoops, sorry peeps, not that one, this one and this one. Okay, so, oh, I see the problem. This has moved. Let me snap it back. Okay. All right. So we were about to distribute the 3 electrons of lithium. Lithium has 3 electrons. S is going to hold 2 out of the 3. How many left over? That leftover electron goes in the 2s. Just because S can hold 2 does not mean I fill it completely. I only have 3 electrons. The first 1s orbital has to hold 2 of them, and then the leftovers go in the last one. Think of the leftover orbital as the people that go to fourth lunch. They only get what's left over from 1, 2, and 3 lunches. Okay? All right. Now, beryllium. Beryllium, what's the location? Second period, because we're doing all the second row elements, right? Second period. And also beryllium is in the S block right there. Okay, so same stopping point as lithium. I have to start at 1s and stop at 2s. Okay, now beryllium has 4 electrons. That's the atomic number. I'm going to give 2 to the 1s because I have to fill that before I move on to the next one. Out of 4, I have used 2. I have left over 2, and both of them will go in beryllium's second orbital. Okay, so those are beryllium's electrons. Now we're going to do boron. What period is boron in? Second period, because we're doing row 2. What block is boron in? Boron is actually in the P block. So that means I must stop at 2p. So 2p is right here. That's my stopping point. I go back to the start. So I write 1s. Then comes 2s diagonally down. Then 2p. How many electrons in boron? 5. I give 2 to 1s because you have to fill before you move to the next one. Then out of 5, I've used 2. I have 3 left. Out of the 3, I'm going to give 2 to 2s. That's 4. I only have 1 left, and that 1 goes into 2p. Okay? P can hold a max of 6. I don't have 6 to fill boron. After I give 2 to 1s and 2 to 2s, I only have 1 left, and that leftover 1 goes into 2p. Okay, it's okay to have 1 electron. You don't have to max it out for the last orbital. Now, carbon is second row, so second period. Again, the p block. So the stopping point for carbon is the same because carbon is right here, right? So we're going to do 1s, 2s, 2p for carbon. How many electrons in carbon? It's 6. I'm going to give 2 to 1s, 2 to 2s, and then how many left over out of 6? 2 left over. The 2p will get 2 in this one. Then nitrogen, second period, p block, stopping point is the same. What comes before 2p? 1s, 2s, then 2p. How many electrons in nitrogen? 7 electrons in nitrogen. Out of 7, 2 go here, 2 go here, that's 4. 3 left over, the 3 go here. Okay? Then, the next one. The element is oxygen. Oxygen is in the second period in the p block. Stopping point is the same. What comes before 2p? 1s, 2s, 2p. Let's fill in electrons. 8 electrons in oxygen. 2, 2, that's 4. 4 left over. The leftover 4 go into the 2p orbital. Then, next one is going to be fluorine. Fluorine is right here. Second period p block. So ending point is still 2p for all of them. 1s, 2s, then 2p. Now I must fill in electrons. 9 electrons. 2 here, 2 here. That's 4. And then the last 5 go into the last orbital. Okay, remember the reason we are putting 2 in S is because S is a 1-room apartment and can only hold 2 people or 2 electrons max. Okay, now neon is still in the second period. It's still in the p block, so it's still 2p, 1s, 2s, 2p. Then let's use yellow. I'm going to put 10 electrons, 2 here, 2 here, that's 4. 6 more will make it 10. Okay? So those are the electron configurations of all second period elements. As you can see, once you find the stopping point, you know what to write before the stopping point, and then you distribute electrons based on the letter. S gets 2, P gets a max of 6, D gets a max of 10. We haven't done any D's yet, and F gets a max of 14. But just because P gets a max of 6 does not mean we put 6 every time we have a P. The last orbital always gets the leftovers. Okay, so that's electron configuration. The main errors come from people just not following the diagonal arrows. You have to follow the arrows from the back to the front. So 1s, 2s, then 2p, then 3s, 3p, then 4s, 3D, 4P, 5S, etc. Okay? The arrows have to be followed in the direction that they're drawn from back to front. Okay, now you are going to practice 3 on your own. Why don't you go ahead and do those? Try them, pause the video, and then see what your answers are. Okay? All right, I'll do the answers right now. The location of sodium is right here. It's in the third period, in the third row in the S block. So my stopping point for sodium is 3S right here. Okay, so if stopping point for sodium is 3S, I have to do 1S, 2S, 2P, and then 3S. Okay. Oh, did not mean to erase that. 1S, 2S, 2P, 3S. Okay, sodium has 11 electrons. 2 go in the 1s, 2 go in the 2s. Now I can give P6, that's 10, and then the leftover 1 goes in the last orbital. Okay, let's do sulfur. Sulfur is right here. Sulfur is in the third period. Let me erase that. Oh, erase that. Sulfur is in the third period in the P block. Okay, so that means it ends in 3P. So before 3P comes 1S, 2S, 2P, 3S, 3P. Okay, so now I'm going to distribute 16 electrons. 2, 2, 6, 16 because sulfur has 16 electrons. Okay, 2, 2, 6, that's 10, 11, 12, 4 left over, 3P4. Okay, sulfur should end in 3P4. Then last one is argon. Last one is argon. We're doing argon. Here is argon right here. Okay, argon is in the third period. It's in the third period in the P block. So it's in 3P. So I have to end in 3P here for argon. So 3P is right there, same as sulfur, which means I have to write everything up to 3P. So that's going to be 1S, 2S, 2P, 3S, 3P. And argon has 18 electrons. So I have to go 2, 2, 6, 2. That's 10, 11, 12. 6 gives me 18. Okay, now here's a cool thing about the periodic table that I want you to note before I do the next video. This is the end of part 1, by the way. Okay, here's a cool thing. I'm gonna look at boron. Let's start with boron. Okay, boron ends in 2p1. Boron is in the p block in the first column, which is why it's p1. The first column is p1. Carbon is ending in p2. Carbon is the column carbon is in is p2. Carbon will end in p2. Any element here will end in p2. Okay? Look at nitrogen. Nitrogen should end in p3. Here is nitrogen, and we also did phosphorus, which is right below nitrogen. No, we didn't do phosphorus. We did sulfur. We'll come back to that. So nitrogen ends in p3. Okay. Then sulfur ends in P4, and so does oxygen. Oxygen and sulfur both end in P4, and they're in the same column. Look at that. They're in the fourth column of the P block, so they end in P4. So you can tell the pattern now. The next column will end in P5, and then this column will end in P6, but not helium. Helium is not supposed to really be there, right? So it's P6. I want you to also notice there are two columns in S block, and there are two electrons that S can hold. P can hold 6 electrons, right? That's why P has 6 columns. S can hold 2 electrons, so this is going to be S1, and that's S2. So that makes sense. If D can hold 10 electrons, there should be 10 columns in the D block. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So zinc should end in something D10. Copper should end in D9. Nickel should end in D8, etc. And what about the F block? F block should have 14 columns. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Okay? So the number of electrons the type of apartment or the sublevel can hold in its maximum capacity reflects the number of columns on the periodic table. All right?